Alright, in this video we are going to cover the multiple roots theorem of polynomials, or the multiplicity of a root of a polynomial. And again, this is a very simple theorem that says if a is a root of the polynomial p of x equals 0 with multiplicity n, so a is a repeated root that repeats n times, then a is also a root of the first derivative of p of x equals 0 with multiplicity n minus 1. So a is a repeated root of p prime x, and it repeats n minus 1 times. So then it follows that if x minus a to the power of n is a root of p of x, then x minus a to the power of n minus 1 is a root of the first derivative of p of x, or p prime x, and x minus a to the power of n minus 2 is a root of p double prime x, and so on and so forth. Alright, so let's try and make sense of this theorem by doing an example. So solve x to the power of 4 minus 6x cubed plus 12x squared minus 10x plus 3 equals 0, given the equation has a root of multiplicity 3. So let's say that a is a root of this polynomial, then x minus a is a factor of this polynomial. So the root a is repeated 3 times, and so is the factor x minus a. So then p of x can be written as x minus a cubed times another factor g of x, and g of x is what we have to solve for. And since x minus a is repeated 3 times in the polynomial, it's when we get to the second derivative where we have x minus a only once as a factor of the second derivative polynomial. So it's x minus a times another polynomial f of x, let's say. Okay, so the first derivative, p prime of x, is equal to 4x cubed minus 18x squared plus 24x minus 10. And the second derivative, p double prime, will be equal to 12x squared minus 36x plus 24. And I'm going to set this equation equal to 0 to find the factors we need. So I can factor out a 12, and this will leave me with 12 outside of x squared minus 3x minus plus 2, equal to 0. And of course we can divide both sides by 12, so effectively it gets rid of the 12 on the left hand side. So we're left with x squared minus 3x plus 2, and this is the equation we have to solve to find the repeated factor. So I can rewrite x squared minus 3x as x squared minus 2x minus x plus 2. And if I factor out an x on the first two terms, I get x outside of x minus 2. And if I factor out a negative 1 in the second two terms, I get negative 1 outside of x minus 2. And of course, if I factorize these two, I get x minus 1 and x minus 2 equaling 0. So the roots of p double prime equals 0 are x equals 1 and x equals 2. And let's test if x equals 1 is a root of the first derivative. So if I sub in p prime of 1, this is equal to 4 times 1 cubed minus 18 times 1 squared plus 24 times 1 minus 10. So we get 4 minus 18, which is negative 14, plus 24, which is positive 10, minus 10 equals 0. So therefore x minus 1 is a factor of p double prime x, and x minus 1 squared is a factor of p prime x. Let's test if p prime of 2 is equal to 0, where we get 4 times 2 cubed minus 18 times 2 squared plus 24 times 2 minus 10, and you can satisfy yourself that this does not actually equal to 0. So x minus 2 is not a factor of the first derivative. And okay, so if this x minus 1 squared is a factor of the first derivative, then it follows that x minus 1 cubed will be a factor of p of x. So with this, I'm going to expand it out. So x minus 1 cubed is equal to x cubed minus 3x squared plus 3x minus 1, and this is simply through binomial expansion. So now I'm going to divide p of x by this expression to find the remaining factor. So we have x to the fourth minus 6x cubed plus 12x squared minus 10x plus 3 divided by x cubed minus 3x squared plus 3x minus 1. Okay, so what do I need to multiply x cubed by to get x to the fourth? I need to multiply it by an x. So x cubed times x is x to the fourth minus 3x cubed plus 3x squared minus x, and I subtract the new line from the line above. So this gives me minus 3x cubed plus 9x squared minus 9x, and I bring down the positive 3 plus 3. And to get minus 3x cubed, I need to multiply by negative 3. So negative 3 times x squared times x cubed gives negative 3x cubed. Negative 3 times negative 3x squared gives positive 9x squared minus 9x positive 3, and of course the remainder then is equal to 0. So therefore p of x can be expressed as x minus 1 cubed by x minus 3. And if you expand this out, you'll find that it will be equal to this. So please give me a like if you have found this video useful in helping you to understand the multiple roots theorem. And please feel free to subscribe to my channel for more tutorials. And by all means, use the comments below to discuss and ask me any question. In the meantime, best of luck with your studies, and I'll see you on the next video.